Okay, what we're going to do today is we're going to go through some examples so you can properly understand the electrical laws that we are learning about. These electrical laws are as follows. First off, we have Ohm's law, which is basically V equals IR. So when we're using this, we need two of these three variables. We need either voltage, current, or resistance. We need two of those three to figure out the third. So we can use this basic equation to help us figure out one of those missing values. The second one is Kirchhoff's current law, and that's illustrated in these two figures. It's basically the current entering any point must equal the current leaving any point. So if you take a look at this first figure here, we've got this point, and we've got these three currents. We've got 5 milliamps, 10 milliamps, 15 milliamps. They are all entering this point together. These three branches are together, and their leaving is 30 milliamps. So that covers that side. Here, we've got the reverse, okay? We've got 30 milliamps, and it's actually branching out into three different currents, okay? So since each one of these branches and the current that's in that branch is going to be proportional to the resistor. The higher resistor is going to give us the lower amount of current. The lower resistor is going to give us the higher amount of current. You can see that in this picture. In this picture over here, you can see that each of the resistors are the same value. So the current is going to split evenly across those three branches. The next thing is Kirchhoff's voltage law. And this basically means that any voltage drops around any closed loop must add up to the voltage supply in that loop. Take a look at these pictures that we have here. We have this 10-volt supply, and then we have each one of these resistors has a 2 volts drop, okay? And we can figure out the value of the voltage drop by the values of the resistors. So the voltage drop is going to be basically comparable or directly proportional to the values of the resistors, okay? So we'll learn a little bit more about that later. If we have a complicated circuit like we're going to solve here today, we're basically going to follow that rule again. So with this complicated circuit, we can create two loops. There's one loop here in this circle, and then over here, you can see if we eliminate that resistor, then there's another loop here in that circle. So that basically means the voltage drop in this circle is going to be equal to the voltage gain. And over here, the voltage drop in this circle is going to be equal to the voltage gain. So we'll see that in the examples that we're about to do. Our first example is here. We're going to find the current and the voltage for all resistors. The very first thing that we're going to do is make a chart. That way we can organize our information, okay? So what we're going to do here is we can easily fill in our resistor values. And you can see that what I've done is I've gone ahead and filled in those values on this chart. So we need to find the voltage and the current that's left in our circuit. So that's what we're going to do on the next slide. Now, in order to do that, we need to keep in mind Kirchhoff's current law and Kirchhoff's voltage law. I've got a couple of equations here that's going to help us out from one of the other PowerPoints that we looked at, this one here. Okay, so we basically copied these equations over to our PowerPoint that we're going to use. So if we take a look at this, we can see that all of this current, we have a current supply, all of this current, all of it is going to pass through this 5 ohm resistor, okay? So what I'm going to do is I'm going to say I1 equals 0.12 amps, okay? Now 120 milliamps is 0.12 amps. And then what we need to do next is we need to figure out how much of that current is going to split and end up with I2, and then how much of it is going to go with R3, okay? So if you can see the resistance that we have here, this 12 ohm resistor is going to be higher, so it's going to be a smaller amount of current, okay? And this equation here is going to help give us that ratio, okay? So I've got this I1, which is the total. That's where that is coming through. So I'm going to go ahead and punch that in, okay? And then I'm getting my ratio with the values here. Okay, so my R3 is 9. I put that in the numerator because that's the lesser of the two values. And in my denominator, I'm going to put the sum of the two, and that's going to be 21. Okay, so the 9 plus 12 is the 21. Now, when I go ahead and do my math, I'm going to have 0.12, and I'll do this simply for you, times points, and I'll carry to 4 decimal places just to kind of keep it true as possible. And when I simplify that again, it's going to be 0.051. Okay, so I've got that through there. All right. Now, in order to find my I3, all I need to do is subtract this I2 from I3. Since some of the current is going to go through this 12 ohm resistor and the rest of it is going to go through the 9 ohm resistor. So all I need to do is I need to post that into this equation here. So I'm going to go ahead and take care of that now. So I've got my 0.12 minus my 0.051, and that is going to give me a value of 0.069. Now that I know the current across all three of the resistors, and I know the resistor values, I can easily find the voltages. So that's what I'm going to do. I'm going to use Ohm's law now to find the remaining values, since I know the others. We're going to go ahead and start with V1. V1 equals I1 times R1, and I'm basically going to put the values in. So I have 0.12 times my 5 ohm resistor, and I do the math, and that's going to give me 0.6 volts. Okay, now the next one I have to figure out is V2, and that is going to be V2 equal to I2 times R2, and that is going to be very simply 0.051 times my 12 ohms, and that's going to give me a voltage of 0.61 volts. Okay, now my voltage 3, if I remember my Kirchhoff's voltage law, I can go ahead and remember that if I close this out, then I can easily figure out what that voltage is, because the voltage in this loop has to be equal to the voltage in that loop. So that, in fact, is going to end up making V2 equal to V3, which means that's 0.61. Okay? Now, if we wanted to, we could go ahead and use Ohm's law just to double check that. And if you're just starting out with circuits, it might be a good idea to do that. So we're going to go ahead and just do a double check to make sure that that is in fact true. So for my current 3, 0.069 times 9 ohms, and that does in fact give me 0.62. So you might see it might vary a little bit, but it's very close. So all I need to do now is just fill in the numbers for my chart, and there they are. Okay, so we are finished this problem. We're going to move on to the next one. We take a look at this one here, we'll see that we have another circuit, but in this case, we've got 2 parallel branches and we have a voltage source. So the first thing I'll do is I'll go ahead and fill in my resistance values in this chart. And you see that's what I've gone ahead and done here. So we're going to go ahead and go to the next slide to do all of our math. Now the first thing we're going to do here is looking at our circuit, we can do voltage first. Okay, so if we take a look at this, and I go ahead and draw on my figure here, and if I cross this loop out and I just look at this loop alone, you can see right away that I only have 2 voltages here. I've got the supply voltage of 24 volts, and I've got the voltage drain for the resistor, which is 75 ohms. So that means that my V1 has to equal that supply, so that's going to be 24 volts. Okay, it has to be equal because there's only one resistor in that loop. Now if I go ahead and I just get rid of this And then I can look at the second loop, and I could cross this loop out using my Kirchhoff's voltage law. I can go ahead and write down a relationship. I know that my V2 plus my V3 has to add up to 24, okay, because of this loop. So these drops have to add up to this gain of 24. So that means I need to do a little bit of math. I need to look at the ratios that I have there. So I'm going to use the ratios of the resistors to help me figure out what those voltages are. It doesn't matter which one that you do first. So what we're going to do is we're going to do V2. Now, if I look at V2, the loop that the value that I'm going to use, I've got my 24 volts and I've got my 50 ohms. And let me use my bracket here. I've got my 50 ohms over the total of 50 plus 45 for my total there, okay? If I simplify that just a little bit, I've got my 24 because that's my voltage, and I'm taking a portion of that, times my 50 over 95, and I do my math, what I'm going to end up with is 12.6. So that's going to be my V2, okay? My V3, sorry about that, my V3 is going to be equal to 24 volts minus V2. So I can go ahead, because of this equation right up here, I just reformatted it. I took that V2 and I subtracted it from both sides. So I have 24 minus 12.6. And what I get here is I get a value of 11.4. Now that I have the voltages across all of these resistors, I can very easily use Ohm's law to figure out the current in these, okay? So the key is to use Kirchhoff's voltage or current laws first to figure out which ones are equal to kind of simplify and get that one value. And then Ohm's law can be used to find everything else, okay? So what I'm going to do first is I'm going to look for I1. Okay, now voltage, Kirchhoff's voltage law, if we look at that, it's V equals IR. But if I go ahead and I solve for I, this is what I'm going to get, V over R. Okay, so for our case, we have I1 equals V1 over R1, and we put our numbers in. We have 24 volts over 75 ohms, and what we get is 0.32 amps. So that's our current for I1, okay? Now we know that since the loop rule, all of these currents in this other loop have to add up to the 0.32. So I know that I2 and I3 actually, yeah, are going to be there. They have to add up to that. Actually, correction, the current going through this branch is going to be different than the current going through that branch, okay? But the current going through each one of these resistors is going to be the same because all of it travels through that, and then all of it travels through that. So what I'm going to do now is I'm going to solve for one of the other currents. I'm going to solve for I2 is going to be equal to V2 over R2. And I go ahead and plug in my numbers. I got 12.6 volts over 50 ohms, and I get 0.25 amps. Okay, now I know from Kirchhoff's current law that that is going to be the same. So I3 is also equal to 0.25 amps. Now, if we want to go ahead and check, we can. Okay, and what we'll do is I3 equals V3 over R3, and we have 11.4 over 45, and that equals 0.25, which it checks out. So we'll go ahead and fill in all of our values, and this is what we have for the second problem. Okay? There you go.